Ever wondered how a simple bunch of dots on a screen can tell a powerful, hidden story? Well, today, we're going to crack the code. We are going to learn the secret language these dots are speaking. So take a look at this. At first glance, it kind of just looks like a random mess of points, right? But believe it or not, there's a story in there about the relationship between a person's age and their income. There's a pattern, a hidden message. But what is it? What you're looking at has a name. It's called a scatterplot, and the definition is actually wonderfully simple. It's literally just a collection of points on a graph. Each one of those points holds two pieces of information, and our job, our mission, is to figure out what they're all trying to tell us together. So to really understand the story these dots are telling, we first have to learn their language. Let's dive into the fundamentals of how you decode one of these plots. Okay, so every single dot you see here is basically a combination of two numbers. It's got a value along that horizontal line at the bottom, that's the x-axis, and another value on the vertical line running up the side, that's the y-axis. Those two numbers together give each dot its own unique little spot on the graph. Let's make this real for a second. In this example, every dot represents one day. Its position from left to right tells you the temperature, and its position up and down tells you the total sales for that day. So a single dot, bam, elegantly connects two totally separate ideas, temperature and sales, into one clear piece of data. All right, now that we know what each individual dot means, we can kind of zoom out, because the real story isn't in any single dot. No, the magic happens when you see the overall shape that all the dots create together. This right here is the first question you should always ask yourself. Just look at the whole collection of dots. Is there a general direction? Are they climbing upwards, maybe sloping downwards, or are they just a big random cloud with no pattern at all? Check this out. It's a perfect side-by-side. On the left, you can see as study time goes up, the marks also go up. Makes sense. But on the right, something different is happening. As the process input increases, the quality actually goes down. It's such a clear visual of an upward trend versus a downward one. Now, we have specific names for these trends. When the dots are trending upwards, meaning as one thing increases, the other thing also increases, we call that a positive association. And when they trend downwards, so as one thing goes up, the other goes down, we call that a negative association. Simple, right? And then, of course, there's the third possibility. Sometimes the dots are just a random, shapeless cloud. And you know what that tells us? It tells us there's probably no relationship at all between the two things we're measuring. We just call this no correlation. But not all relationships are created equal. The story the data is telling can be a faint whisper, or it can be a really confident shout. So let's look at how we can tell just how strong that story is. We'll start here with a whisper. This is a weak positive correlation. You can kind of see that the dots are generally heading up and to the right, but man, they are really spread out. The trend is there, but it's pretty loose. Now watch what happens as a relationship gets stronger. The dots start to pull in closer together. They get more disciplined. This is what we'd call a moderate positive correlation. The pattern is much, much clearer now. And finally, we get this shout. This is the strongest possible relationship, a perfect positive correlation. Look at that. All the dots fall on a single, perfect straight line. There is absolutely no doubt about the story here. It is crystal clear. So how do we summarize the main trend, especially when it isn't perfect like that? Well, we use a really cool tool called the line of best fit. I love this analogy. Think of it as the story's headline. It's the one single line that we try to be as close as possible to all the dots. And here it is in action. Even though all those points are scattered around, this line of best fit instantly shows us the main story in the data. And that story is, generally speaking, the more hours a student studied, the higher their exam score was. But you know, a lot of the time, the most interesting parts of a story aren't the main plot. They're the unexpected twists. And in data, these are the points that just don't follow the rules. We call these little rule breakers outliers. An outlier is simply a data point that really stands out because it's so different from everything else. It's the exception to the rule, and trust me, it often has the most interesting story to tell. Okay, time to put on your detective hat. This scatter plot shows test scores versus how many hours of sleep someone got. Now, most of the dots follow a nice pattern. More sleep, higher score. But do you see one point that completely breaks that trend? Take a look. You see it? That red dot way down in the corner. That's our outlier. Now we have to ask, What's its story? It represents someone who got a full 9 hours of sleep but still got a very low test score. Why? Maybe they didn't study, or maybe they were feeling sick that day. See, outliers force us to look beyond the main trend and start asking these really important, deeper questions. This visual makes it perfectly clear. While most of the points are huddled around that general trend line, the outlier is just sitting way out there on its own. And these exceptions, they aren't just interesting, they're often critical. In a factory, one outlier might signal a faulty machine. In finance, it could be a fraudulent transaction. Finding them can save a company millions or even prevent a crisis. And there you have it. You're officially a data detective. Seriously, in just a few minutes, you've learned how to look at a cloud of dots and spot the direction of a relationship, judge its strength, find the overall trend, and even hunt down those crucial, interesting outliers. So why does this matter so much? Because as the technologist Andrew McAfee once said, the world is one big data problem. Being able to understand the stories that data tells us is an absolutely essential skill in our modern world. So I'm going to leave you with one final challenge. Here is a scatter plot showing flash recovery time versus volts after flash. Now that you speak the language of the dots, I have just one question for you. What story do you think these dots are trying to tell?